Hi, girlies.
What are you doing?
Shut up.
I'm not here for it.
Okay, 7-5.
I did really good. Did you do mapping for reading? Mapping slows me down. Really? Well, my score really went down.
Okay, 7.5 talks about applying properties of logarithmic functions. Okay, talk to me a little bit about what you know about powers. Okay, if you have something that says this, 7 squared times 7 cubed, what do?
Exponents.
You add the exponents. Okay, we're gonna pretend for some reason this isn't. You add the exponents, okay? If you have 7 cubed over 7 squared, what do? You subtract the exponents, okay? What happens when I have this? You multiply. We're gonna apply those same three rules to logarithmic functions. Okay? So if I have, and for some reason my PowerPoint won't go away from here, I don't know why. If I have log base b, okay, of m times n, so if I have this right here, log base b of m times n, okay, I can split it up to say log base b of m plus log base b of n. Because they're being multiplied together, I can add them. Just like when I have exponents, when I multiply them together, I'm adding them. Okay? Quotient property, log base b of m over n. If I have log base b of m over n, that means I subtract them. Okay? Same here, I subtract. And then the power property, when I do it this way, when it's a log base b of m to the n power, I'm taking that n in front and I'm multiplying it. Okay? Just like you multiply powers. Because logarithmic functions are powers. Okay? Then they're going to give us problems that say, evaluate this function. Okay? Here's the deal. I want to evaluate this function, and it says use log base 4 of 3 and log base 4 of 7. That means everything has to be in terms of 3 and 7. This should say like this. Everything should be in terms of 3 and 7. So if this says log base 4 of 3 over log base 4 of 7, what am I actually doing?
Yes, Bob?
You subtract.
You do what? You subtract.
Chris will have to replace individual.
Let me put these back on.
You subtract. You subtract. So you have log base 4 of 3 minus log base 4 of 7. You subtract. Now, they gave us numbers that they represent, so I'm going to take these and I'm going to plug them in. So you have 0.792 minus 1.404. Okay? What happens when you subtract those?
You get a negative.
You get a negative. So I do 0.792 minus 1.404. I get negative 0.612. That is how I evaluate. Now, over here I have log base 4 of 21. Is that in terms of 7 and 3? No, but can I get it into terms of 7 and 3?
Sure.
Yes, how?
Times 3.
Okay, so I can break it down to say log 4 of 7 times 3. What happens when you multiply? You are doing what? Adding. So I have log base 4 of 7 plus log base 4 of 3. Log base 4 of 7 is 1.404. Plus log base 4 of 3 is 0.792. So my answer is 1.404 plus 0.792, 1.404 plus 0.792,
I can already tell you the answer to figure this out.
you get 2.196.
I think.
Okay. On C, what do you do?
Break it down to 7 and 7.
Okay, so 7 and 7, or another way of saying that is 7
Long.
squared. Squared.
I think it's
So log 4 of 7 squared. What happens to the squared when I have a power? What do I do to that? What? I think you're right. What did you say? I'm going to take this 2 and I'm going to put it in front of here. Okay? Because I'm multiplying, because it was a power of a power. Power of a power. Multiply. So then I'm plugging into this 1.404. What is 1.404 times 2?
2.808.
Beautiful.
Boom.
Okay? That's when they want us to evaluate. Okay? Now, they want us to simply expand this, meaning I'm not going to get a number answer. I'm just expanding what's happening. Okay? We're going to go every step. So the first thing that I see here is that it says log base 6 of 5x cubed over y. What do I need to do to that? If I have it divided, divide means subtract. So I'm going to say log base 6 of 5x cubed minus log base 6 of y. Okay, now I'm going to focus on this part. What is 5 and x doing? They're multiplying, so that means I have to put what there? If multiplying goes with what? Adding. So I have to say log base 6 of 5 plus log base 6 of x cubed minus log base 6 of y. Log base 6 of 5, is there anything else I can do there? No. Can I do anything here with log base 6 of x cubed?
No.
Yeah. Yeah, take the 3 into the front.
Yeah.
Okay? So I'm going to say log base 6 of 5 plus 3 log base 6 of x minus log base 6 of y. Now, I've expanded it. What are you throwing?
I don't know, something's in the hallway. I just saw a leg. I think.
Okay, so now I've expanded it as far as I can. That's how we expand logarithmic functions. Or natural log, the same rules apply. Okay? Now, look at this one. You have, it says which of the following is equivalent to log 9 plus 3 log 2 minus log 3? Okay? See. I see this right away. What is this? Tell me that's actually happening.
Addition.
Which means I am multiplying. So I'm going to change that to say log 9 times, and what does this out here tell me I need to do? Yeah, times 2.
Really? Are you serious?
What is so funny?
Frankie don't even know. She's laughing.
Okay, times 2 cubed. What's the minus sign tell me? Divide. So I'm going to divide it by 3. The log can just stay out in front of all of it now. Now I've condensed that statement down. Now I just have to do math.
2 equals 4 times 2 equals 8.
What? Yeah, 2 cubed is 8. What's 8 times 9? 172 divided by 3. So you get log 24.
I don't even know.
Here, I'll practice like you guys did yesterday.
I was
Well, the
trying to
ACT
do it.
sucked
The
yesterday.
doubles got
Okay,
me.
so you get log 24. Okay, now, let's talk about this. Remember how you've had equations that look like this before and we've said you can't do anything with it? Where you have like log base 6 of 12. And I'm like, well, I can't plug that in my calculator because what is my common log base on my calculator? Okay, and what's my natural log base on my calculator?
1, 5. 1, 5, 15. Oh.
Natural log.
Oh, natural.
Natural log. Okay. So we're going to talk about if you see something in this form, we can solve this now. We can solve it using change of base. Okay? change of base says this, if I have log base C of A, or natural log base E of A, okay? I can change it so that the bases are the same so I can divide them. The large number goes on top, the small number goes on bottom, okay? So what that means is this, it says evaluate log 3 of 8 using common log and natural log. Common log is which one?
L-O-G.
Yes, LOG. So if I have log 3 of 8, okay, I can change that to, and I want to see you change it on your homework, to log 8 over log 3.
Okay.
What does log 8 over log 3 can come out to be congruent to?
No. Eight divided.
Yeah, it comes out, Layton's right, it comes out to approximately 1.89, okay? Now, if I want to do it in natural log, what is natural log?
L-N.
So I would have ln of 3, ln base 3 of 8. So I would change it to ln 8 again, large over the small. And what does that come out to be? The same thing. So does it matter which one you use? When it says use change of base, you can choose. I just need you to show me that you know how to do this. Okay? So when it says evaluate using change of base, boom. Okay, last thing. For a sound with intensity of I in watts per square meter, the loudest, or the loudness of L of I of the sound in decibels is given by the function L of I equals 10 log I over I sub base 0, where I sub base 0 is the intensity of a barely audible sound. Barely, I know I can't. About 10 to the negative 12 watts per square meter. An artist in a recording studio turns up the volume of a track so that the sound's intensity doubles. Okay, which means how many times bigger is that? 2. Okay, and he's turning up the intensity. What does the intensity? The intensity is just measured by I. Okay, he wants to know by how many decibels does the loudness increase? Okay, how can I figure that out? Find I, is that what you said? Kind of. Well, look at this 10 log I over I0. What's happening there? What are 2 rules that are happening there?
Subtracting.
Subtracting, yep.
And
And that 10 in front means what?
it was the power.
Yeah, okay. So this is where I started, was at 10,
Oh.
okay, was,
Oh, yeah.
Alright.
yes, love it when that's.
Ready, shut?
I can't, okay. So it was at 10 log of I over I sub base 0. But we want to subtract that from the new amount. And the new amount was double the intensity, but only double the intensity. And that's the intensity. So it would be 10 log 2I over I sub base 0. Now, if I break this back down, I can leave the 10 because both of them have 10s. I can just leave it on the outside for now. So I can say 10, and then I can break this down to say, how does log 2I and log I sub base 0 break down?
It will be
What happens with that division?
No.
Division means what?
Subtraction.
Subtraction. So log 2I minus log of I sub base 0. Now, over here, I already have a subtraction sign, right? So if I have a subtraction sign and I break this down, that means I do subtraction of log of I, right? Log I. Minus log I. And then here, technically it's a double negative because this is subtraction within itself here, yes?
Yeah.
So, plus log times 0. Okay, right? Did I miss something? I feel like I missed something.
So I see 2 cancel out. I see, log 2.
I feel like I missed something. Give me a second here. 2i minus I.
Get it together, Ariana.
They didn't separate it all the way. Okay, so
It was one time statement.
those should cancel. These should all cancel. This should cancel, right? I think it should be log 2.
Yeah, what should we say?
Do I not have to separate? Oh.
Oh, yeah.
Oh, I know what they did. They made it so that this actually becomes void. And then you get this. You get 10 log 2. Because this cancels out, the i's cancel out, leaving you with log 2. So then you can change this to say log. No. You can take 10 log 2 and put it in your calculator right from there. Because the base is just nothing, so it means it's a 10. So what is 10 log 2 come out to be? 3.0. So it increased by 3 decimal levels. Okay? All your homework should be done pretty much on your calculator tonight. So you can get busy and do that.